Hi students, this is Miss Oberly, and today our lesson target is I can apply scale factors to determine the areas and side lengths of geometric figures. Before we start, say with me please, once I say it first by myself, area is length times width or base times height divided by 2. Say it with me, please, right now on 2. 1, 2. Area is length times width or base times height divided by 2. Please pause the video, have the person closest to the window teach this to their partner, and then person closest to the door teach this to their partner. When you're finished, you can continue playing the video. All right, now that we have that in our head, we're going to be using that all day today. So, question 1, now that you have the sheet in front of you, asks, what is the scale factor from the small to the large rectangle? Pause the video and try it on your own, please. Hi, Juan.
Okay.
How are you doing?
Good.
Good. I'm just recording a video because I'm going to be out tomorrow, but you'll be a leader tomorrow, won't you?
Yeah. Wait, who's going to be here tomorrow?
Mrs. Belkengren. She's been our sub before.
She's old.
Well, I guess you could say that, yeah. All right, I'm going to keep recording here. Scale factor, remember, is new over original, so 5 over 1 or 5. They ask you next to find x in question number 2. So pause the video with your partner, set up this proportion, and solve. All right, I'm going to set up my proportion as length over width equals length over width. So I have 4 over 1 equals x over 5. And I can see an easy relationship here. From 1 to 4, I multiply by 4. So from 5 to x, if I multiply by 4, I will see x equals 20. Question 3, what is the area of each rectangle? Pause the video, work with your partner to find the area of the small rectangle and the area of the large rectangle. Go ahead. All right, you're ready for checking the areas? Remember, area is length times width. So the small area is 4 times 1, which is 4. The large area will be, we just found x is 20. So we will be doing length times width, which is 20, times 5, which we know is 100. How many of you got that right? Good. All right, question 4 we're going to do together, so you don't need to pause the video. Question 4 says, how is scale factor related to the ratios of the areas? So our scale factor, remember, was 5. If we compare the ratios of our areas, we can see that is 100 divided by 4, which I know is 25. How are 5 and 25 related? Can you think of a way that 5 and 25 are related? Well, 5 squared is 25. So if we take our scale factor and square it, it will give us the ratios of our areas, 25. That's true every time. So kind of an exciting relationship. In math, we're always looking for patterns, and this is one of them. All right, let's go on to number 5. Please pause the video, read number 5 with your partner, and then answer number 5, and then play the video to check your work. Okay, so they ask us for the area of they ask us the scale factor from the small to the large. Well, I can see that this is 6 units, this is 12 units, And scale factor is always new over original. So our new shape is 12 to 6, which is the same thing as 2. How many of you got a scale factor of 2? Nice job. All right, now they ask you in question number 6 to find the area of each rectangle. Pause the video, please, and then play it later to check. Okay, so to find area, remember area is length times width for a rectangle. So I need to know the width of both of these rectangles. So if I count this, I can see this is 6. And of our small rectangle, length times width would be 6 times 3, which is 18. In our large rectangle, length times width is 12 times 6, which is 72. How is scale factor related to the ratios of the areas? Look back at question 4 with this, pause the video, and then play it to check your answer. Okay, so remember our scale factor was 2, and our areas are 72 to 18. 72 divided by 18 is 4. And the way that 2 is related to 4, let's change colors here, is that 2 squared, or a scale factor squared, is 4. So that's always going to be true. Your areas will be related by your scale factor squared. All right, let's look at question 8 together. What is the scale factor from the small to the large triangle? Pause the video and then play it to see the answer, to check your answer. All right, scale factor is new over original. So we're going from small to large. So our large is our new shape. Our original is our smaller shape. 6 divided by 3, oops, is not 6. Let me erase that. 6 divided by 3 is 2. Question 9 asks, using the two triangles to the right, what are the areas of each? Remember, for area of a triangle, it's not length times width anymore. It's base times height divided by 2. So base times height are always the two sides that form a right angle divided by 2. Pause the video, try this one, and then play it to see how close you were. All right, area is base times height, so 3 times 4 divided by 2. Order of operations, as we do everything up here first, so 12 divided by 2, and 12 divided by 2 is 6. Area of the large triangle, again, is base times height divided by 2, so 6 times 8 divided by 2. And I know that 6 times 8 is 48, and 48 divided by 2 is 24. How is scale factor related to the ratios of the areas? Pause the video, give this one a shot, and then play for the answer. All right, the areas are related by 24. Oops. 24 is to 6. So 24 divided by 6 is 4. Remember, our scale factor was 2, and the cool thing is 2 squared is the same as 4. So it's working out again that our scale factor squared, or our scale factor times itself, is 4 every single time, even with triangles. All right, number 11. Question number 11 says, draw and label the known side lengths of both the small and the large triangle. I'd like you to do this separately. So I'm going to ask you now to draw a small triangle and go ahead and label them for what we know. And then also draw a large triangle and label them based on what we know in this picture. All right, so the small triangle is 12 and 5. The large triangle, what is this length across the bottom? Are you noticing it's 12 plus 12, which is 24? Do we know what this height is? It's x. Could you find x before we go on? Take a minute with your partner, set up a proportion, and find x. All right, have you tried to find x on your own first? I'm noticing there's a relationship of times 2 here. So 5 times 2 tells me that this has to be 10. All right, what is the area of triangle ABE? So that's the small triangle. Well, remember, area is base times height divided by 2 when we're working with triangles. So pause the video, find the area of both the small and the large triangle, and then play it to check your answer. All right, so our area of our small triangle is 30 feet squared. The area of the large triangle is 120 feet squared. If you got that right, you are absolutely on track. Scale factor we noticed is times 2, or new over original, 10 divided by 5, which is 2. How is that scale factor related to the area of the ratios? Well, we're hoping that the scale factor squared equals the area of the ratio, or the ratios of the area. So let's check that. That would be 120 divided by 30. We're hoping that's going to equal 4. Well, 12 divided by 3 is 4. So that scale factor squared does equal the ratio of our areas. All right, finally, the challenge says the ratio of the sides of a square fence A to the sides of a square fence B is 3:1. If the area of fence A is 36 feet, what is the area of fence B? Draw a picture to help. Pause the video and see if you can sketch this. That's the trickiest part. All right, so we've got fence A, we've got fence B. Oh, and actually it says it's square, so let me erase that. Is it not going to let me erase that? I drew rectangles, but I want to draw squares here. All right, so fence A, whoa, that's a crazy looking square. Fence B. And they say the ratio is 3:1. In other words, the scale factor here is going to be times 3. Okay, so now if we know that scale factor, we have to think about if the area of fence A is 36 feet. So if area is 36 feet, what does that mean the length of each of the sides would have to be? What times what gives us 36? If you're thinking 6 times 6, you are correct. And I am not going to answer this for you, but I want you to think of if the scale factor is 3, so we have to do times 3 here, what would each of these side lengths have to be? Which means you could answer the question. Reread to see what the question is. All right. Thank you for having a good day. I'll see you tomorrow, or I'll see you Monday.